In this video lesson, we're going to talk about literal equations, sometimes called solve for a variable. Suppose you have the equation t equals 9c plus 8d, and the directions say to solve for d. What that's telling us is that we want the equation to be in d equals form. So I'm going to put a box around the d. I need to solve for d by getting rid of all of the terms and the coefficients of d. So the first thing to do here would be to move the term 9c. And I can do that by subtracting 9c. Remember that if you subtract 9c on one side, you have to do it also on the other side. This effectively removes 9c from the right-hand side of the equation. You're left with t minus 9c on the left. Since these are not like terms, we just write t minus 9c. I'm going to bring down the equal sign, and over here we're left with positive 8d. Now remember, my goal is to get d alone, to get the equation in d equals form. So if I look over here with the d, I see that the coefficient of d is 8. And to get rid of the 8, I can multiply both sides by 1/8. Now, when I multiply the left-hand side by 1/8, that's going to be the same as saying t minus 9c all over 8. And 1/8 times 8d is 1d, or just d. d is alone, so I have now solved for d. d is equal to t minus 9c divided by 8. When you're solving for a variable, you're doing the same thing you would do with normal equations. The difference here is you have more than one variable in the equation. All right, in this next example, we're asked to solve for m. So I'm going to find m and kind of highlight it. Now, in order for me to get m alone, I see that m has the coefficients xr, or you could say it's being multiplied by x and r. Also, to this term is being added xr squared. Well, you always want to get rid of the extraneous terms. So in this case, I'm going to get rid of the term xr squared. And I can do that by subtracting. If you do that on one side, you will have to do it on the other side. On the left-hand side, I see I have s minus xr squared. They are not like terms, so I'm just going to write it out like this. And bring down my equal sign. Over here, I'm still left with the term xrm, but I had xr squared minus xr squared, which made a zero pair, so that's eliminated. Okay, I'm still trying to solve for m. The only thing left to do now is to get rid of the coefficients of m, which are x and r. They're both being multiplied by m. Remember that to get rid of a coefficient of a variable, you can multiply by the reciprocal of the coefficient. So the reciprocal of xr is 1 over xr, 1 over xr. So when I multiply this side by 1 over xr, I end up with s minus xr squared in the numerator and xr in the denominator. Over here, 1 over xr times xr is 1. So I'm left with 1m, or just m. And I'm finished. I've solved for m. All right, in this next example, I have c equals 4n plus 10nk, and I'm asked to solve for n. Now, this one's different because I have an n in both of those terms. Well, if you go back to your distributive property, I can rewrite this as n times 4 plus 10k. How did I know that? Well, if you redistribute the n, you get 4n plus 10 times k times n, or 10nk. So I use my distributive property to get the n out. All right. Now, remember, we're trying to get n alone. This is saying n times the quantity 4 plus 10k. N times whatever's in parentheses. If I had written 4 or c equals n times 6, if I had written that, you would say, okay, you can multiply both sides by 1/6. Or you could multiply, or you could divide both sides by 6 if you wanted to think of it that way. And you end up with c over 6 equals n. Well, This isn't 6. This is 4 plus 10k. So I can multiply both sides by the reciprocal of this. So that'd be 1 over 4 plus 10k. So that's going to leave me with c over 4 plus 10k equals n. N is alone. So I'm finished with that problem. Sometimes it's helpful to take a simpler problem like I did over here and ask yourself, how would you solve this? And then reapply it to the problem that you're working at. A lot of times this will make things a lot more clear for you. All right, and then the last example is A equals LW. This is actually the formula for area of a rectangle. Area equals length times width. So you're asked to solve for W. There it is. So I want to get W alone. This says L times W. You can think of it as that L is the coefficient of W, and we know that we can multiply by the reciprocal of the coefficient to eliminate it. So that's one way that we can do it. This one was a pretty simple problem. If you wanted to think about it in terms of division, you could say, well, instead of multiplying by L, I can divide both sides by L, and that would work too. Either way. So W is equal to A divided by L.